Yeah, good evening. And happy Sunday and happy new month to everyone. So in today's class, we have quite a lot to cover. Uh, we've been able to move quite deep into calculus. Yesterday we delved into much more complex aspects around using first principle. And I believe everyone in this class should be very much familiar with uh, differentiation using first principle at this point. Uh, Today we will be covering quite a number of subjects. We'll be talking about exponential functions while dealing with calculus. We'll be talking about polynomial functions. We'll be talking about logarithm functions. Then we'll also be talking about derivative of variable power. And we'll also talk about inverse functions around circular functions. That situation where we have arc sine x, arc cos x, and the likes. And then also, if time permits us, we will get into some of these methodologies around differentiation, which we have been doing a bit of it. I'm talking about the use of quotient rule, product rule, chain rule, and the likes. So let's get started. We're going to be starting with polynomial functions. All right. So as usual, I would expect you to take good notes. Please jot carefully, ensure you're flowing with us so that you can get the best from the class. So let's start from polynomial functions. Of course, I'm sure we are mostly familiar with this already, so we will not spend much time on this. So polynomial functions, how do we make the differentiation of polynomial functions? Well, quite very simple. I believe we already talked about polynomials in our classes already, and I'm sure you know what polynomials are. So a very good example of polynomial is, for instance, we have 2x squared, 3x squared plus 3x. Those are all polynomial functions. So let's get right into an example, and I'm sure everyone here should be able to differentiate polynomial functions. However, this is I'm going to assume you don't know it so that we can be able to explain properly. So let's take, for instance, we have a polynomial function of this form, y equals to ax raised to the power of n. Now, if you have a situation like this, and you are asked to find the derivative of y with respect to x, I'm sure you understand that the derivative of x with respect to y is derived from the derivative of y with respect to x. So when we say derivative of y with respect to it, that's when we write the y over the x. Now, how do we go with differentiating polynomial functions of this form? Well, what you have to do is for you to it's quite very simple. You see this power here, you'll be multiplying it with this coefficient of x. So in this case now, you'll be having n times a. And then you'll be having, this is the continuation, x raised to power n, you subtract 1 from the power. So this is the general rule, which I'm sure you quite understand this already. So let's just quickly try to resolve this quickly using examples. For instance, if I have y equals to x raised to power 2, applying this principle, this means the y over the x will be equals to, again, I said you multiply the power with the coefficient, that will be 2 times 1, which is 2. If I wanted to write it much in this form, I would say 2, coefficient is 1, then x raised to the power 2 minus 1. That will be 2x raised to the power 1. That will be what? 2x. Very simple, yeah? Look at another one. We have y equals to 4x raised to the power of 2. How do we solve this question if you are to find the derivative of y with respect to x? Again, you will multiply the power with the coefficient. That will be 2 times 4. Then the x, you subtract 1 from the power. This will be 8x raised to the power of 1, which is equivalent to 8x. You can see how simple this is. So well, let's do some quite quickly. We don't have to waste time. Just be telling me the answer right in the chat box. If you have y equals to x squared minus 2, what are you going to get here? If you have y equals to 1 over x, what are you going to get here? If you have y equals to a, we'll talk about that very soon. Then if you have y equals to 5x raised to the power of 4 minus 1 over 2 x raised to the power of 3 plus 3x squared, then minus 6. All right, and then let me put 2 more, or 3 more rather. So we have another one, y equals to what? X squared plus 5x minus 8. And we have this one also, y equals to 4x raised to the power 5 over 5 minus 2 over 3x raised to the power of 3. Then we have plus 2 over x. Then we have minus 3 over x squared. So, and I think the last but not the least will be y equals to, we have x plus 1 over x raised to the power of 2. So these are the questions I would like you to give me responses to. So let me check and see what you guys are doing. So this will help you and aid you to understand polynomial functions perfectly. So let's start from the very first one. What's your answer there? The first one, of course, this first one, the y over the x will be equals to what? Now, let me quickly say one thing, because some of you may probably be confused that we did not do anything that has to do with just 2. Like, what do I do here? Now, let me just prove that to you. Of course, when you want to solve something like this, you do for each of them. So, according to what I said here, 2x raised to the power 2 will be 2 times 1. That will be 2x raised to the power 2 minus 1. Then minus, let's do for 2 now and see what will happen now. Okay, you know what I'm going to do? Let me rewrite this equation more properly. Look at x squared minus 2x raised to the power 0. Just note this, that this is the same thing as this. So this will help you better. Just ignore this. So let me do the y over the x here, so that anyone paying attention will be able to flow with why we have the answer we're going to be getting. So of course this will be 2 times 1. That will be 2x raised to the power 2 minus 1. Let's try and do for this one. This will be 0 times 2 times x raised to the power 0 minus 1. Following the same process. This will be 2x raised to the power 1 minus all this. You know, 0 times anything will give you what? 0. That means the final answer will be 2x. Right? So you can see why we're going to get our answer as 2x. Right? So let's leave that. I'm sure you understand what's happening here. So just note that when you have a constant, that means a constant is something that doesn't have x in it. Just note that differentiating a constant will always give you 0. Differentiating a constant will always give you 0. Because once you don't have x in any expression, you won't be able to get any other answer other than 0. So that's that about that. Let's see the next one. The next question there we have y being equals to 1 over x. Now, how do you solve this one? You would have to try and get this into a better place by writing it as x raised to the power minus 1. This works much better because the initial thing we have here, don't forget it has a power. So it's good for you to put it in such a form that it has a power. And I'm sure you know that 1 over x is equivalent to x raised to the power minus 1. So the y over the x here will be equals to what? Again, the same rule, minus 1 times the coefficient here is 1, then x raised to the power minus 1 minus 1, following the rule. This will be minus 1 times 1, that's minus 1. X raised to the power minus 1 is minus 2. This will be minus x raised to the power minus 2. All right, this is the answer, but we can change the form and write it as minus, then we have 1 over x raised to the power 2, because we know x raised to the power minus 2 is the same thing as 1 over x raised to the power 2. So the answer now is either this, you can leave it in this form or in this form. They are both correct. How many of you got that? So here we go. The next question we have y being equals to a. Of course, I told you already, if you have y being equals to a, what's going to be your dy over the x? Now, of course, you can rewrite this as y equals to a x raised to the power 0, because you know x raised to the power 0 is obviously the same thing as 1. So this is writing a times 1, which is a x raised to the power 0. But for the sake of us being able to use this method, we can write it as this. So we try to do the y over the x here. This will obviously be 0 times a, the coefficient of x, then x raised to the power 0 minus 1. Following this rule, that will be 0. So the differentiation of y of that y with respect to x is 0. So let's see the next one. We'll be faster now. I believe you have understood the method, so we don't have to waste time here at all. We have a lot to do. Let's move this with this very quickly. If you have the y over the x, here we would go very quick. That will be 5 times 4. That will be 20 x raised to the power. Then you subtract 1 from the power 3. That's for the first one. For this next one, you will have your minus here. 3 times 1 over 2. That will be 3 over 2. X raised to the power what? 3 minus 1. That will be 2. I'm sure you can flow with me. I'm sure I'm not too fast for anybody. And then the third one, the third expression there, 3x squared. That will be plus 2 times 3. That will be 6. 6x raised to the power. Subtract 1 from the power 1. That will be 6x. That's minus 6. I already told you already, when you are differentiating a constant, you get 0. So that will be minus 0, which you don't have to put. So this is the answer right there. All right. Now let's see the next one. For this one, we have x squared. We can do this very quickly also. The y over the x here will be equals to what? That will be 2x. That will be 2 times the coefficient, which is 1. That's 2x. X raised to the power what? 2 minus 1. That's 1. So we don't have to put it. We can just ignore that, because 2x raised to the power 1 is the same thing as 2x. Then for this one, we have plus. Of course, we have the x raised to the power 1 here. That will be 1 times 5. That will be 5 x raised to the power. There is a 1 there, don't forget. 1 minus 1. That's 1 minus 1 is 0. That will be 5 x raised to the power 0. And what's x raised to the power 0? X raised to the power 0 is 1. So we have it as just 5. This is a constant. Of course, we have done that several times now. That will be minus 0. We don't have to add that. So this is the answer for this question. All right. I'm sure you guys are being able to flow properly. For this other one, how do you do this other one? The same way, you just have to move quietly and rightly. So the y over the x of this one will be equals to, just follow the same rule. The coefficient here is 4 over 5 of x. So that will be 5 times 4 over 5. That will be 5 times 4 over 5. Then you have x raised to the power 5 minus 1. That will be the first term. That will be what the first term will be. If you do this, okay, let's try and do this, the next one first. This will be 3 times 2 over 3. Then x raised to the power 3 minus 1. All right, I'm sure you can flow with what we're doing. Now, the next one, this will be plus, this is different now. You have 2 over x. So how do you do 2 over x? 2 over x is the same thing as writing, this one is the same thing as writing 2 times 1 over x, which is the same thing as 2x raised to power minus 1. So can you see how we're able to change this form to this one? So this is what we're going to use to now solve what we have here instead of this. So you adjust this form to look like this so that you'll be able to solve much properly. So after doing it like that now, you can go on now to do minus 1 times 2. That'll be minus 2. Then x raised to power minus 1 minus 1. And the last one there, of course, the last one there we have 3 over x squared. If you have 3 over x squared, I'm sure you know what to do there also. 3 over x squared will be the same thing as 3 into 1 minus 1 over x squared, which is the same thing as 3 x raised to power minus 2. So all this is how you'll be looking at it now. So you'll be using this one to make your differentiation. All right. So that'll be minus 2 times 3. That'll be, let me write it in full, minus 2 times 3. Then x raised to power, minus 2 times 3, then x raised to power minus 2 minus 1, according to the rule. So our final answer here, obviously, 5 we cancel 5, will be having 4x raised to power 5 minus 5, that will be 4, minus 3 we cancel 3, we'll be left with 2x raised to power 2, then plus, of course, plus this will be minus 2, so this will automatically change to minus. Now minus 2x raised to power what? Minus 2. Then this one will be minus times minus 6. That will be plus 6 raised to power x raised to power what? Minus 3. Because minus 2 minus 1 is minus 3. How many of you got this final answer, this particular one? How many of you were able to get this particular answer? So this is, you can see the way we solve it. I hope I'm not too fast for anybody, because I really believe that this is something that I think you guys should be able to flow with. So this last question, all right, this last question we are doing now, normally I'm sure some of you can see it, this last one, the one for what, this one right here. I'm sure many of you are seeing it and you're feeling like, oh, we're going to use chain rule here. Yes, you can use chain rule, but because we are under polynomial functions, we will not be using chain rule. All right, we'll be using an expansion so that we can bring it to a much clearer polynomial. So imagine you had this question and you didn't want to use chain rule. What do you want to do? Of course, you want to open the bracket. That will be having x squared plus 2 times x times 1 over x, then plus 1 over x all square. I'm sure you understand that aspect of algebra. This is x squared. Of course, this cancels this, plus 2, then plus 1 over x squared. So now you have your y has this now. So this has been brought to this. So now we can go on to find the y over the x now. The y over the x will be 2x here. For this will be 2x. I'm sure you know that now. This will turn to 0. It's a constant. And for this, of course, this can be written as x raised to power minus 2. This can be written as x raised to power minus 2. So that will be plus minus 2 times 1, x raised to power minus 2 minus 1. So this will be 2x minus 2x raised to power minus 3. This is your final answer. So if you want to, you can write it as 2x minus 2, 1 over x raised to power 3. That will obviously be 2x minus 2 over x raised to power 3. So you can write it this way. You can write it this way. Whichever one is correct. I'm sure I hope I'm not being too fast. I really want to confirm that. I just want to cover quite a number of things today. So I hope this went well. I hope you can flow what I did. I had this question. I didn't want to use chain rule, so I expanded it. I expanded using the normal algebra rule, and then I got this. Then obviously I went on to differentiate this now, and this was all I got. So, and I can bring this to this also. All right. So that's nice. So now let's go quickly to exponential functions. So this is all about polynomial functions. So you should be able to solve any question given in this sense. All right. So let's go quickly to exponential function. This is another part of calculus that students do have issues in because they don't understand the concept. And it's quite very simple. because it's probably more simpler than even polynomial functions if you understand the concept. So we have exponential functions next, and it's very simple. Let's see briefly an example. Of course, when you're talking of exponential function, in case you have forgotten, this is what we are talking about. For instance, when you have y being equals to e raised to power x, or y being equals to 3 e raised to power x minus 1, things like this, y being equals to 4 e raised to power 3x plus 3. So these are all exponential functions. So you see, all these are examples of exponential functions. This is the exponential part. So of course, these are all other variables around it. So let's talk quickly about exponential functions, and let's see, and you will see how easy it is to solve them. So let's just write a general form of exponential function. Let's write y being equals to, of course, a e raised to power. Let's put f of x here. All right, let's just put f of x here. Now this, if you thank God we have examples here, so you can relate clearly. In this first example now, your a here is 1 because the coefficient of the exponential in this case is 1. So a here is 1, and then your f of x, which is your function on top, is x in this particular case. Whereas in this one, your a is 3, and your function is x minus 1. In this other last one, the third one, your a is 4, and your function is 3x plus 3. So you can see the general form. We just made this the general form. All right. So now let's see what our dy over dx will be. So our dy over dx is very simple. Very, very simple. You know what you have to do to always get a perfect answer? If you are going to differentiate a function that has exponential, what you just have to do is, number 1, write the a back. Number 2, multiply that a with the derivative of this f of x. This is the derivative of f of x. You can see it there. That means you will differentiate this power. In this case now, you differentiate this power. You can see this. You differentiate this power, you differentiate this power. This is what I mean by f prime of x. This is the derivative of this function, which is the power. Is the power we are differentiating. Don't forget, the power is what represented f of x here. So this is f prime of x. All right. Now, the last part now will be for you to just repeat the exponential. So that will be e raised to power f of x. So look at what's going on here. You can see already that the only thing that will change when you have your exponential function is that you go on to differentiate the power of the exponential and multiply it with the coefficient of whatever your exponential was before. That's all. This is the only added thing. So it's like this was existing, then you differentiate this and you are getting very similar to this same thing, only that you'll be multiplying your a with the differentiation of f of x. Is that simple? All right. So let's see. Let's move now and let's see examples. So you look at this first example now, how simple this is. We have y being equals to e raised to power 3x plus 2. So we have y being equals to e raised to power 3x plus 2. So look at the whole thing. Number 1, identify what your f of x here. Your f of x here is what? 3x plus 2. So you have identified that your f of x, which is the power of exponential, is 3x plus 2. So go on now and find the differentiation of that f of x. That's the f prime of x, which is the differentiation of this. You are differentiating this with respect to x. That's the meaning of f prime of x. So if you differentiate this, what do you get? Of course, I'm sure you all know the differentiation for that is 3. We just did that, right? This is a polynomial function. So the differentiation of 3x plus 2 is 3. Good. So what's going to be my answer for this function derivative? So the y over dx is the same thing as, what's my a here? Let me quickly add, what's my a here? My a here, which is the coefficient of e, is 1. So look at now. My answer will be that 1, the a, of course, whatever a was, multiplied by the differentiation of the power, that's 3, multiplied by the exponential itself, that'll be e raised to power 3x plus 2. So that means the y dx is actually equals to 3e 3x plus 2. That's all. This is actually all. Okay, someone said I'm too fast. Okay. Okay, now let me come over with exponential again. So I started with giving you formats of exponentials. You can see them. They could be probably a little bit more complex than this sometimes, but they always take this form. Now, when you have your exponential function, these are the likelihood of how it will look like. You will have the coefficient of your exponential function. In this particular first case, this a is 1 because coefficient here is 1. Then you have the power of the e. The power of the e here is x. So f of x for this case is x. Now, if you want to make the differentiation of that function, what you have to just do is very simple. It's almost like you write the whole function, because look at it. E raised by fx, e raised by fx. But the difference would be that you'll be multiplying this a with whatever the differentiation of the derivative of f of x is. So whatever the power is, you go and differentiate it. All right, you will differentiate the power and you would multiply it with a. Then you multiply that whole thing with the e raised to power fx. So, and that will be your answer. So see the first example we had. We had y being equals to e raised to power 3x plus 2. Of course, we know already that our fx now is 3x plus 2 because our fx is whatever was the power of e. So the power of the exponential is fx. So fx now is 3x plus 2. So we have to go on to differentiate that power, which is 3x plus 2. That's what we did here. So we went on to differentiate 3x plus 2. We got 3. Good. So we have gotten our fx. We knew our fx. We have gotten the derivative of that fx. Now we went on to identify what is our a. That means what's the coefficient of the exponential function. In this particular example, the coefficient here is 1. So our a is 1. So the answer for the derivative of the whole function, this function, that means the differentiating y here, this function now, differentiating this function with respect to x, the y over the x, that's what that means, will be the the coefficient, that's a, times the derivative of the function. You can see it here, the derivative of the function, that's 3. And then you go on to repeat the whatever e raised by fx was. This is e raised by fx. So this is 1 times 3, that's 3 e raised by 3x plus 2. So before I even go on to write any more examples, I want to quickly do for all these 3. So let's do for all these 3 very quickly. So for us to do the y over the x here, the y over the x here, very simple. What is your a first? My a for this case, my a is 1. The coefficient here is 1. What was my fx? My fx is x. So what's the f prime of x here? If fx is x, what is f, the differentiation of f prime of x? That will be 1. If fx equals to x, of course f prime of x, that's the differentiation of f of x, will be 1. I'm sure you know that. So now what's going to be my dy over dx? My dy over dx will be the coefficient of the exponential, that will be 1, times the derivative of that function, the power, that will be 1 here. And then you go on to just rewrite the exponential, that will be e raised to power x. So dy over dx for this one is the same thing as e raised to power x. That's the first one. Let's do for the second one. All right. The second one now, we have, in this case, our a is what? Our a is 3. Now our f of x is x minus 1. That's the power here. You can see that's x minus 1. Then the derivative of that, our power, will be what? If you differentiate x, you will get 1. You know, the derivative of this whole function is 1. Good. So what's going to be my dy over dx? The y over dx will be equals to, we said a, whatever a is, that's 3, times the derivative of that power, that's 1 in this case, then e raised to power, what you just rewrite the e raised to power x minus 1. So you can see this will be 3 e raised to power x minus 1. That's the answer for this second one. So it's so simple. Anybody can do this. I really believe anybody can do this. So let's do for that last one, y being equals to 4 e raised to power 3x plus 3. So in this case, what's my a? Coefficient of e here, my a is 4. All right, my a here is 4, is it not? And my function, that's the power of e, is what? 3x plus 3. the power of e. So what's the derivative of this power of e? That means what's f prime of x? If I ask you to differentiate 3x plus 3, what will you tell me my answer is? Of course, the answer will be 3. So how do I get the y over the x now? I'll just say the y over the x is equals to, and I will say a, that's the first thing, a times the derivative of that power, that's 3. Then I will now go on to just write this e raised to power 3x plus 3. So the final answer here will be what? That will be 12 e raised to power 3x plus 3. Are you seeing it? So quite very simple. So now that I know you have that understanding, I want to give you examples now. You will do it and you tell me what the answers are. So that's the best way to practice, because if you were not flowing properly, at least you'll be able to flow while you do it yourself. So y equals to, let's say we have e raised to power minus ax plus b. Then y equals to e raised to power minus 4x squared plus 2x. Then let's say y equals to e raised to power sine x. Okay. I think the last but not the least will be y equals to e raised to power 2x squared minus 7x plus 1. Now, please let me first indicate, were you able to flow with me? Did you really understand what I just explained about exponential function? Please, can I get feedback? Did you understand if you know you didn't understand, please can you indicate if you are still having issues with understanding what I just said, all the things I just said? Is anybody here still not able to understand exponential functions? Okay, and please let me get more feedback. I understand exponential function properly now. I'm able to solve any question on it. Can you indicate, please? Okay. I want more people. Can you please give me your feedback? It really helps to. Okay. I want more feedback, please. If you know you understand it, please can you indicate you really understand it now? It's clear to you. There's no misunderstanding at all. Can I get more feedback? Okay. So all right, great. So can you attempt this? We're going to attempt this together now. Can you attempt this? Can you attempt these 4 questions? And let's see how it goes. Okay. So okay. So we're going to start from the very first one. When you want to solve these questions, you need to understand the basics. That's why I left this for you to see. So y in this case is equals to e raised to power minus ax plus b. Please give me your answer to this if you are done with it. Give me your answer to this if you're done with it. It will really help you. So now look at it. In this case now, the coefficient of my exponential is a, which is 1. So a here is 1. All right, a is 1. Now, what is my fx based on what I'm explaining? My fx here is the power of e, and the power of e here is equals to minus ax plus b. I'm sure you can all see that this is the power right here, the power of e. Okay, so what do you do next after identifying the power of e? What you do next is to go on to differentiate that power of e, which I believe we just did. This is polynomial functions. So when you have this function minus ax plus b, if you are going to differentiate this, what are you going to get? Of course, that's why you needed to have known polynomial functions. Your answer will be minus a. All right, based on, now please let me quickly say one thing. The a here is not the same thing as the a here. This a, we can decide not to use a. This a is based on just saying the coefficient of my exponential. It's not the same thing here. This exponential had a as part of the variable, so it's actually a constant, but it has a there. So just don't misunderstand them. So that's f prime of x. That's the derivative of this function with respect to x. So now that we're done with this, these are the two important things. You get your a, you get your derivative of your function, the power of the exponential. Once you are done with those two things, you are good. You can, once you identify the coefficient of your exponential and you identify the power of your exponential and you're able to find the derivative of the power of your exponential, you are perfect to go. So all you need to do is go on and just say, okay, if I've gotten these two things, the y over dx will be equals to, you will start with the coefficient, that's a, that will be 1 times, then you will multiply it with the derivative of the function of the power, that's minus a. 1 times minus a, then you go on to just rewrite the exponential itself, e raised to power minus ax plus b. So this will be obviously minus a e raised to power minus ax plus b. It's simple and straightforward. How many of you got this? When we got this answer, you got it perfectly. This is what exactly what you got. Can you indicate you got this answer? You got this answer. So now, okay. Now, I will use, if you did not get this first one, of course, you would understand with the second one. Let's keep moving. Now, we have another function here. We have, look at the function, this function 2. We have y being equals to e raised to power minus, now we have 4x squared plus 2x. All right, this is what we have here. Good. Now, I told you the two things you want to quickly identify is, number one, what's the coefficient of your exponential? The coefficient of the exponential here is 1. Of course, you don't see anything staying close to e apart from 1. So the coefficient here is 1. Now, what is my function, my f of x, which is the power of the exponential? The power of the exponential here is minus 4x squared plus 2x. Now, it is better you open it as in full and write it as minus 4x squared minus 2x. This is good. So what's the next thing you want to do? You want to go on to find the derivative of that f of x, that power. So go on to now find f prime of x. Of course, I believe everybody can differentiate this. This is a polynomial function, right? So this will be minus 8x, that's minus 2 times 4. 2 times minus 4, that's minus 8x, then minus 2. All right. So I told you the two important things you want is the coefficient and this derivative. Once you have gotten those two things, you are good to go. You can solve any exponential question. You can find the derivative of any exponential once you get these two things. So how do I get my dy over dx? My dy over dx now will be equals to what? You will multiply this coefficient, that's 1 in this case, with that derivative, that's minus 8x minus 2. Then all you need to do is go on to just rewrite the exponential with its power, e raised to power, in this case, write e raised to power minus 4x squared plus 2x. All right. So if you want to, you can decide to bring out, factorize minus out. All these ones I want to write next is format. It's not, this is the correct answer. I can write it as minus 8x minus 2 e raised to power minus 4. Don't forget to use your bracket too. Minus 4x squared plus 2. That's the answer if you want to leave it that way, or you can decide to write it as minus 8x plus 2 and e raised to power minus 4x squared plus 2. How many of you got this answer? How many of you got this answer? You were able to get this answer. How many of you got this exact answer? Okay. I like that. I love that. Okay, I love that. So I love that you are able to flow. That's nice. That's great. So once you see any exponential question, just follow this rule and you can't go wrong. So let's see the third one. The third one, y being equals to what? E raised to power sine x. Okay, so y is equals to sine e raised to power sine x. Okay, you will probably be feeling that this is quite a difficult one. It's still the same thing. the first thing you want to identify is what's the coefficient of the exponential. That's what we called a. That's all these are nomenclature. So for my own, I'm using a. You may be using a different alphabet for your own. A here is 1. What's my function? My f of x, which is the power of the exponential. My fx here is sine x. So what's going to be my f prime of x? Of course, if fx is sine x, if I differentiate on sine x, what do I get? I get cos x. That's why you need to understand all these things. So if I differentiate sine x, I get cos x. Good. So now that I've gotten my cos x, what do I do next? I want to find the y over the x of this. So the y over the x of this will be equals to what? I multiply my the coefficient with the derivative. That'll be 1 times cos x. Then you just write e raised whatever the exponential was e raised to whatever it was, sine x. So this will obviously be cos x e raised to power sine x. Are you guys seeing that math is quite very simple? It's just about understanding a concept. I'm sure some of you felt these things were very difficult before. You felt that when you see e raised to power sine x, it's just so hard to get. This is the process, and this is the answer. Wherever you see this, you don't mix things up. Just follow the step. You always get it right. So the last but not the least we have right there is this last one we have right there, and that is y being equals to e raised to power what we have here. So let's solve this last one. So again, it's the same process. No matter how complex they look, just follow the same process. So the first thing is we want to identify what is our a, the coefficient of my exponential. For some reasons, all the coefficient here was 1. It doesn't have to always be like that. It can be 2, it may be 3, it may be anything. So it could even be something else, not constant values. But whatever it is, just identify the coefficient. Coefficient here is 1. What's my fx? My fx here is 2x squared minus 7x plus 1. Okay, so I want to go and find my f prime x, which is the derivative of this function fx. That will be 4x squared, sorry, 4x, not 4x squared, 4x minus 7, and that's all. So that's my f prime of x. So I want to find the y over the x now. The y over the x will be equals to what? I multiply my constant with that fx, that'll be 1 times 4x minus 7. Then I go on to write the whole exponential. That'll be e raised to power 2x squared minus 7x plus 1. And that's all. So of course this one will be 1 times this. You understand? That will be 1 times this will be this. So that's the final answer. All right. So all right. So I think at this point I've been able to convince you on this concept, and I believe everybody is quite familiar now with this. I don't think this should cause you any form of stress in an exam or anymore. So that's nice, and it's good that you guys are flowing. So it's time to move on to the next. So what's the next now? The next is logarithm functions. Okay, so and we're going to, this one is probably even simpler than exponential function. Probably simpler than exponential function. All these things, they just have names, they have looks, and if you are not very careful, they will scare you and intimidate you. But if you are right with the concept, you can never go wrong with it. All right, so let's run quickly to logarithm functions. So log functions. Good. Yesterday, while we were in class yesterday, I explained something about ln and logarithm functions, and I really want you to be able to identify the difference between that these are the same thing. I don't want you to go and be confusing yourself unnecessarily. That was why I said something like this yesterday. I don't know if you remember that if you see ln x and you see log base e of x, they are the same thing. I think I explained that yesterday. So now let's consider this function. Of course, when we say log function, you know that it's better we write the logarithm there. So let's just use log e of x as a basic. This is logarithm functions. So you'll be having questions that may have something around log and everything. So if you're asked to differentiate this, what is the principle around this? So now, I'm going to just show you a background knowledge of this, and then we're going to go. I will just give you the same way I did for exponential, where you just follow a pattern, you always get your answer. Then I'm going to do that. So let's quickly do a background knowledge of this. If I'm going to write this as indices, I'm sure you know I'm going to write this as e raised to power y equals to x. I'm sure everybody agrees with this. So, and if I go on to wanting to do, let me write it as x equals to e raised to power y, because it looks much neater this way. So if I want to find the x now over the y, that means if I want to differentiate this function x now, not function y, if I want to differentiate function x with respect to y, we did that yesterday. I'm sure we did a question like this, and I'm sure you were able to. If you go back to the video, you will see where we did something where we were solving for the x over the y initially, and then later on we now inverted it, right? So the x over the y, if you followed normally, it's supposed to be e raised to power y. This is constant. If you are differentiating this with respect to this is what you get. Of course, I don't need to say so much. I'm sure we just did exponential function. So you can see this exponential function. So if you want to prove me wrong and say, are you sure? I have x equals to an exponential function of y, right? So if I want to differentiate this x, you know what I'm supposed to do. What's the constant here? The constant here is 1. What's the function? The function is y. If I do the y over the x, the y, if I differentiate this function, I will get 1. And then I will just rewrite the function e raised to power y. You can see that this 1 times 1 e raised to power y. That's why we said the answer is e raised to power y. So good that you know exponential function already. Somebody is questioning how we're able to move from here to here. Differentiate this one with respect to y, you will get this thing back. Try it anywhere, you will get the same answer. All right. Now look at what we're now dealing with. If I want to find the y over the x, now I found the x over the y. If I want to find the y over the x, this will be, of course, I will invert it. I will take the reciprocal, so that will be 1 over e raised to power y. Now, don't forget that we told you already that e raised to power y was something here, it was x. So this obviously will be equals to 1 over x. Now, look at this. This is on the basis we are going to use to build up the metrics that we always work for this. So look at it now, the y over the x. We had, look at what we had, though. This was what we had. And we're able to find the y over the x as this. Now, look at something that happened here. Then you will understand what really happened. When we wanted to differentiate this, I just did this as background knowledge. What you just need to do is to go on to say, what is your function? And in this case, you're going to write, permit me to write this thing in a format that you will be able to understand well. I'll write this as y equals to log e. Now, I'll be writing fx the same way I did when I was solving for exponential. The same way I did when I was solving exponential, where I said e raised to power fx. I'm sure you understand. And then I was always defining whatever was the power of e as fx. That's the same way I want to do here, that I want to be defining whatever the logarithm was that I was doing, whatever this place was. Maybe x plus 1, maybe 3x squared, it may be 4x squared plus 2. Whatever this place is, let me just call it fx. Let me just call that fx, just for quick understanding. So this is, whatever is here, we will be calling it fx. We'll call it fx. So if I want to differentiate this, that means if I want to get the y over the x of this, all I just need to do is quite very simple. I will go on to differentiate this fx. So this is what you will always do. F prime x over fx. That's the answer. That's always going to be the answer. This is what we will be doing every time we have logarithm function. And you'll see how simple this is now. So let's take the first example now. The first example is what we have done already. And let's see if it works. This is the first example when we had y equals to log ex. So let's assume we don't know our answer. Of course, we have done it here. We've gotten the answer to be 1 over x. Let's say we don't know that answer. Let's try and use this particular format to try and solve it. And let's see if it will work or not. Okay. Now, we said in this case now, you can see that, let's first of all identify what our fx. Our fx here is x. You can see fx, whatever the logarithm was. So our fx here is what? X. right? We have identified that. So now, what is f prime of x? Of course, how are you differentiating? If I ask you to differentiate fx, what is going to be your answer? If I ask you to differentiate this, what's going to be your answer? Your answer will be 1. All right. Now, that means if I'm following this format now, that means the differentiation of this function y with respect to x, following this format, you said whatever the derivative of that fx is will be on the top. What's the derivative of this function x? This is it, 1. That will be on the top, 1. Then the function itself will be under x. And you see we got the same answer. How many of you were able to flow with what I just said? Quite very simple. You have a logarithm function. Just go on to identify. The only thing you need to identify in that logarithm function, in this particular case, the only thing you need to identify is this fx, whatever your log was saying. Maybe log e x plus 1, maybe log e 3x squared. That 3x squared, if it was 3x squared, would be your fx. Now, if you are done identifying that, the next thing you have to go and do is go on to differentiate it. So now, if you are done identifying the function and you have gotten its derivative, what you just need to do is to go on to put the derivative over the function. Derivative over the function, that's always going to be your answer. So you can see in this case now, we had derivative 1 over the function x, and that's all. So now we're going to apply this to several examples, and then you will be able to see how it works very easily. So whenever you see questions that has to do with logarithm, this is what you have to do. So let's say the first one, y equals to log e 2x. Can you give me my answer for that quickly? And we'll solve it together, obviously. But for those of you that have not yet understood, don't worry, we're going to solve it together. Let's say we have this 3x squared plus 2x minus 6. Then let's say y equals to log e sine x. Then let's say we have y being equals to ln x squared over x squared plus 1. All right. Okay. So now, before we solve these 4 questions, let me do one more for you people. Then you will start to solve that one, so that at least for whoever wasn't able to flow, you will be able to at least see from this other one. Let's say y was equals to log e, and let's say 3x squared. Let's just put 3x squared here. So let's say you are asked to find the differentiation of this logarithm function. Look at the logarithm function now. We have log e 3x squared. So what are you going to do? See, there's only one thing you have to do first, and that's for you to go on and identify your fx. Your fx is always whatever your logarithm was. That's in this case 3x squared. So my fx now is equals to 3x squared. All right. So if fx equals to 3x squared, what's going to be my derivative of my fx? My derivative here is obviously going to be 6x, right? So what's going to be my dy dx of this? I've identified the function, I've done the derivative. What's going to be the y over the x? The y over the x is obviously going to be, I said, the derivative over the function. This is the derivative, 6x over 3x squared. You can break this further. This will be 2 over x. I'm sure you can see that, because x will cancel one of this x. You'll be left with only one x under. 3 will go here, 1, 3 will go here, 2. That'll be 2 over x. So that's the derivative of That's the y dx of this function. All right, so start throwing to me the answers for all these questions. The very first one, what's your answer? So the very first one, what's your answer? Now, just to add this up, it's all these basics that will help you and aid you to be able to answer any question given. It's almost like the common adage that says little drops of water makes up the mighty ocean. So while you understand all these basics, you may probably not see exactly as much simple question as this. You may have a much more complex one, but it's the accumulation of all this understanding that will help you to be able to answer all these questions. So when you have this question that we have y being equals to log e to x, of course, what's my fx here? My fx here is 2x. So what's my derivative of my fx here? My derivative here is 2. And I say, what's my dy over dx? My dy over dx is what? Derivative over the function. That will be 1 over x. Simple, right? Good. Number 2. What's number 2? Number 2, we have y being equals to log e 3x squared plus 2x minus 6. All right. Now, how do you solve this? First of all, identify your fx. This is your fx here, whatever your log was. So our fx is equals to 3x squared plus 2x minus 6. All right. So you have to go on to find the derivative of this, which will be what? 6x plus 2. All right. So 6x plus 2, that's gotten. So what's going to be my dy over dx? I said dy over dx is always derivative over the function. That will be 6x plus 2 over 3x squared plus 2x minus 6. So can you see how simple these things are? Just knowing the concept will always give you an edge. So if you are asked to differentiate this now, look at the answer. This is the answer. I'm sure this would have looked like impossible before you understood it much clearly. So look at how, you'll be looking at how am I going to differentiate this. It's so simple. This is the answer. So let's see the third one. The third one there, we have log, the natural logarithm of sine x. So y is the natural logarithm of sine x. All right. So how do you find the natural logarithm of sine x? Of course, the first thing is for you to go on to identify the function. The function here is sine x. So what's f prime of x? F prime of x here is cos x. So what's going to be my derivative? The y over the x is obviously derivative over the function. That will be cos x over sine x. And I'm sure you remember, if you know your trig identity, you know that tan x is equals to sine x over cos x. So obviously, this is like an inverted tan, because tan is sine over cos. So obviously, this will be 1 over tan x, which is the same thing as what? Cot x. Cot x. You can see how nice all these things are. Now, the last but not the least, I believe you have this one. So this question, it's coming in a form where some of you may be, it's very important you see it like this so that you don't get confused. When I told you already when we started logarithm function, and when you see ln and log e, they are the same thing. So it's almost as good as writing log e. It's like I could have written log e here instead of ln. So just understand that. So that's the very first thing. Now, in this case now, you want to solve this. So the question is, what are you going to do? Now, you can go through you need to understand your laws of logarithm. And there are some basics that you must understand when dealing with calculus. Calculus is more like, it's going to test your understanding of several topics in mathematics. It will test your algebra understanding. It will test your trigonometry understanding. It will test your indices understanding. It will test your logarithm understanding. So if you're having issues with all those ones, you may probably have issues with calculus a lot. So look at what we have here. Using my law of indices, my law of logarithm rather, I can move in two different formats. Now, this is the first format I'm going to write. If I write this, I can rewrite this as ln x squared multiplied by 1 over x squared plus 1. I'm sure nobody is disapproving of what I just wrote. Like, I can write this as this. I'm still okay. Now, this is, of course, this dot I put here is times. I'm sure you understand that. Right, let me just use the dot as it is so that times and x are not mistaken from with each other. So now, if you have this, there's a law in logarithm that tells you what to do in a case like this. And what's the law? What does the law say? The law says that when you have a question, a situation like this, you are supposed to add them together. So this is the same thing as writing y equals to ln x squared plus ln 1 over x squared plus 1. This is standard logarithm law. Now, I'm going to do the other example, the other possibility right here. Let me use this whole place. I'm sure we understand this already. So I can flow through this direction and I can flow through another direction. Look at the other direction. This same thing. Look at what I can write it as. I can write it as y equals to ln. Now, I can use my division rule now. That means I will look at these two things as divided by. And what that tells me under logarithm is that when I have a case like that, I should take it as minus. So it's x squared, ln x squared minus ln x squared plus 1. This is just logarithm law. This is, I'm sure you know that if you are given this question like this, you can change it to this. If you're given a question like this, you can change it to this. Division is minus, subtraction under logarithm. And if I decide to express it like this, multiplication is addition. So these two things, if I follow either this part, if I follow this part or follow this part, I'll get the same answer. So let's start with this part and let's see where it leads us to. And then we'll come back here. So none of you is there confused like, oh, I didn't do this minus, I use this one. You get the same answer. It's mathematics. Once you do the right thing, you always get the same answer. So I want to differentiate this now. I want to get the y over the x. And I know you understand that when dealing with differentiation, when you have situations like when you are adding or subtracting, you do it one at a time. You do for each. So in this case now, you go on to differentiate this. You do go on to differentiate this. So if I want to solve this, I cannot just go on to put them as one. I have to do them individually. So let me, of course, you understand that this is log e also. So you know the same rule we have been doing applies. So let me do for this ln x squared first. So for ln x squared, what's my f of x? My fx here is ln x squared is the same thing as log e x squared. So my f of x is x squared. I'm sure I hope I'm not too far from anybody. I want to differentiate this ln x squared. Ln x squared is the same thing as log e x squared. So following the same rule that we have been using for all the many questions we have solved, you know that your fx is x squared here. And then you can go on to find the derivative of this fx, which will be what? 2x. So to get the y over the x now of this particular ln x squared, the y over the x will be equals to, of course, derivative over the function. That will be 2x over x squared. That will be what? 2 over x. So that's the derivative of this one. We have completed for this one, just this one. We have to go and do for this one. So let's do for this one. For this one where we have ln, which is the same thing as ln x squared plus 1, which is the same thing as log e x squared plus 1. I'm sure you agree with that. So the same rule follows. So what's my fx here? This is my fx. So my fx here is x squared plus 1. So what's the derivative? The derivative of my fx here will be equals to 2x. So what's going to be my dy over dx? The y over dx will obviously be the derivative over the function. That will be 2x over x squared plus 1. All right. So now we have been able to do the derivative of ln x squared, and we have done for ln x squared plus 1. So obviously now, if you want to go on to find the final answer, don't forget we are doing for this whole thing. It's not just for individual. So we have to go on to solve to bring them all together. So the y over the x, of course, of this whole thing and this one, which is this one also, will be the same thing as you will bring that of ln x squared, which is 2 over x. That will be 2 over x minus, there's a minus in between, then the derivative of this one, which is 2x over x squared plus 1. All right, so this is where we are at, and then we can now go on to, of course, find the you can go on to find the LCM. That will be x and x squared plus 1. So when you do this, you'll be getting 2 into x squared plus 1 minus 2x into x. So obviously, you can obviously open this. Permit me to use this space on top here. Let me just bring it here. From here, I'm coming here. So opening this, I will have 2x squared plus 2 minus 2x squared over x times x squared plus 1. So you can see that 2x squared, we cancel 2x squared here. We're left with 2 over x times x squared plus 1. That's our answer, all right? So this is the derivative of this answer here. Is the derivative of this 2 over x times x squared plus 1. How many of you got this answer? Just this answer perfectly. How many of you were able to arrive at this particular answer, this exact answer? So this is me flowing through using this one. I used this one now. I decided to just make it as division. So let me quickly do for this one in case I decide not to do division. So what's going to be my approach? So I've done for this one. I'm sure you look at the answer right here. So let me solve with this one. So if I'm going to do with this one, of course, I already know the answer for ln x squared, which is 2 over x. So this is 2 over x. But I don't know for this yet. So I need to go and do for this. So can you quickly, for those of you that have not, can you quickly try to make the differentiation of this function? What's going to be? So, of course, how do you do this? If you have ln 1 over x squared plus 1, how do you go about solving this? Your f of x here is equals to 1 over x squared plus 1. So, how do you differentiate that? Can you go on to differentiate that very quickly? What do you get? Of course, in this case, you will have to use what we call chain rule. And let me just erase this up and tell you what you're going to get. So I'm trying to solve for this side. So this is this function ln 1 over x squared plus 1. So if I extract my function as 1 over x squared plus 1, of course, you know the deal. We have to go on to find the derivative of f prime x. So, of course, I will not be doing that here because we will still be covering chain rule. But you use chain rule to solve this. This is what you are going to get. You're going to get 2x minus 2x over x squared plus 1. This is what you're going to get. Minus 2x over x squared plus 1 square. This is what you're going to get. If you are having, if you know how to apply chain rule, if you differentiate this, of course, it's not very easy to differentiate this function without using chain rule. It's not probably possible. You have to use chain rule. This is what you're going to get. So now, don't forget now, we are still trying to find the derivative of this one. This is a very nice question to ask you. Look at this question and like find the derivative of this one. So you will have to differentiate that using chain rule. And then I now want to go on now and do the normal thing. That's f prime x over fx. So this is f prime x minus 2x over x squared plus 1 square divided by, let me just use this symbol, divided by, what was my fx? My fx was 1 over x squared plus 1. So of course, you know this will be minus 2x over x squared plus 1 square times x squared plus 1 over 1. You invert it and you get this. So you can see that this will cancel one of it. You'll be left with minus 2x over x squared plus 1. Are you seeing that already? Are you seeing how nice this is? So we have been able to differentiate this now, this particular function here. This is the answer. So now look at what we're going to now do for us to get the final answer, because we have gotten for this, we know for this. So that means my dy over dx will be equals to what did we get for this? We got 2 over x for this. Then plus minus 2x, that's for this other side now. Minus 2x over x squared plus 1. I'm using this second scenario so that in case anybody needs to know it. So of course, all this return to minus. So let's just change it like that. So we have the LCM now. We have x squared plus 1 and we have x. So this will be 2 into x squared plus 1 minus 2x x. I'm sure you understand LCM. So you do this now, you'll be getting 2x squared plus 2 minus 2x squared. This cancels this. We are left with 2 over x into x squared plus 1, which is the same answer we got here. Can you see? 2 over x squared plus 1. So any way you move through, you will get the same answer. That's all I'm trying to prove to you right here. So you just need to be mathematical. That's all that really matters. So guys, I think we have been able to perfect this aspect of calculus. That's logarithm function. Is there anybody still struggling, or are you guys perfect in it very much? Is there any concern around this, or are you very good at it now? So that's the way you solve logarithm function. Derivative of fx over fx, you will always get your answer. So that's that about logarithm function. So we have done polynomial functions, we have done exponential functions, we have done polynomial, we have done exponential, we have done logarithm. Now we want to go into derivative of variable power. Derivative of variable power. I'm going to give you something very easy. Very, very easy. This what I want, the method I want to explain to you is very easy. Derivative of variable power. This is another example on calculus. Now I told you already, in this under calculus is not something that you would say, I'm having issue with calculus. Majorly, if you have issue with calculus, what you need to find out is all these different aspects. Once you have issues with all these different aspects, the possibility for you having issues is very high. But once you're able to know all these different, how to solve exponential, how to solve logarithm function, how to solve polynomial functions, you will not have issues. I can assure you. So now we want to talk about derivative of variable power. This is an example. Let me just give you how questions like this used to go. So let's say, for instance, we have y equals to a raised to power 2x, for instance. This is an example of variable power. All right, variable power, where you are dealing with things like this is not exponential, this is not logarithm, this is just a variable, and you are asked to look at it. You're asked to find the differentiation of this. I don't know, I need to give you a bit of background on this. Everything we have been solving, we said exponential. In that case, you saw an e raised to power something. We said polynomial. When we said polynomial, you had a situation where you said y equals to maybe 3x squared plus 2x. This is polynomial. So you were able to solve questions like this. We said exponential, you said y equals to e raised to power maybe x plus 1. All right. Then we said logarithm function. We said log e raised to power maybe x plus 1 as an example. Or we said it's the same thing as writing ln x plus 1. Now, what if you have a situation where you're not having, look at it now, your x is not, this is not e, this is not log, this is not a polynomial function, this is just a variable. They just told you that y equals to a raised to power 2x. How do you differentiate something like this? How do you go about differentiating? This is not exponential, so you can't apply the rule of exponential here. This is not logarithm, you can't apply the rule of logarithm here. So how do you solve questions like this? You need to really pay attention. So I want to make it quite very easy. So I'm going to just give you a very quick method to use. It will always work. That's the point to this class, is easy method that will always give you your answer. So now look at this. You're given if you're given this kind of situation where you are asked to find the derivative of y with respect to x. So let me just write a general form. You know, it's always important we write a general form. So this is a particular form. Let's write a more general form. A general form will be you having y equals to, we said variable power. So we can have a variable, let's still call it a variable a. Then it has a power, that's the meaning of variable power. So let's just call this power fx as we have been doing. So let's call it fx. That means it could be anything. It could be 2x plus 1, it could be 3x squared plus 2. It could be, this power could be anything. It could be logarithm, it could be anything. It could be a logarithm function. Do you understand? Like, it could be a logarithm function, it could be an exponential function, it could be anything. Fx could be anything. Please note that fx doesn't necessarily have to be a simple term like 2x. Fx could still be an exponential function, it could still be a logarithm function, it could be anything. But what's essential is that fx was the power of a variable. So you're asked to find the y over the x. Now, what do you do? Now, we don't want to waste time. Yeah, there's a very there's a process to this that I don't want to take you through. So what you're just going to do, if you have this kind of situation, is that this is what you are going to use to get your dy over the x every time. Every time I say, number one, write this function again. Just write it as a fx. Now, whatever you look at, this is AO, the variable. Take the natural logarithm of that variable, ln A. Then go on to do the derivative of the power. This is what you have to always do. This is what you have to always do. So now, once you do this, you always get any question that has to do with variable power. So it's like you're giving, let's use y equals to a raised to power 2x now as a very beautiful example. The first thing you want to do is you will be writing the variable power. Then you will take the natural logarithm of that variable, the variable alone, and then you will multiply all these things with the derivative of the power of the variable. So that's how you're going to be able to differentiate a question that has situations like this, variable power. So let's see y equals to a raised to power 2x. So y equals to a raised to power 2x. That's a very beautiful example now. Now, you can see your variable here is a. I did not say your variable must always be a, but here your variable is a. Now, your fx, let's first identify our fx, which is the power of the variable. Your fx here is 2x. All right? Your fx is 2x. Now, you can go on now to find the derivative of that fx, which will be what? 2. If you differentiate fx here, you'll be getting 2. Now, what will be the y over the x based on everything I just said? Look at it. I will say the y over the x will be equals to, of course, you know, you can arrange all these things in a much better, it doesn't have to follow this arrangement. You can put this and this as the first. But just so you understand, I will write this a raised to power 2x. I will rewrite, all right? The same thing, just rewrite it. Multiply that with natural logarithm. I will use log e here. You can use e ln also, whichever one you use. But let me use log e. Log e. You can use any. You can use ln of the variable. That's log e a. Then I'll multiply that with the what? The derivative of the fx. In this case, the derivative is what? 2. So this means my final answer will obviously be 2 a raised to power 2x log ea. Are you seeing that? That's the final answer. So this is how you solve questions that has to do with variable power. Just to recap quickly, the first thing is when you have a variable power like this, a raised to power 2x, go on to say, okay, what's my function, which is the power? My function here is 2x. Good. Go on to find the derivative of that function. The derivative here is 2, because if I differentiate 2x, I get 2. Now, what you want to do is to get the y over the x is you will multiply that function, that's a raised to power 2x, with the natural logarithm of the variable, which is a. Then you multiply with the derivative of the function 2. This is going to be your answer. And you will always get this answer every time you do it, every time. So let's solve some and you will see how much this will always work. Let's say we have a variable power of y equals to a raised to power 2x plus 1. 2x plus 1. So we have y equals to a raised to power 2x plus 1. So how do we solve this? Again, if you had this question without knowing this technique, it's going to be probably a lot of a long process. And you need to be very, you need to find a way to understand and note all these processes without mixing them up. So the very first thing I want to do to get my dy over dx, as I said, you repeat this whole thing. You just write a raised to power 2x plus 1. That's the first thing. Then I will take the natural logarithm of the variable as log e a. Then I will go on to multiply with the derivative. Okay, sorry, I should have brought out what was my f of x. My f of x is what? 2x plus 1. So what's f prime of x here? My f prime of x here is 2. So that will be times 2. So the final answer of the y over dx based on this question will be 2a 2x plus 1 log e a. You will be surprised that you will see some students acing exams. It's all these simple techniques that they know. Once you know all these simple techniques, the most difficult looking calculus question is sometimes so easy if you understand it very well. So look at it. If you look at an answer like this, someone will be feeling this has gone through a whole lot of great process. But we did not. What process do we do here? We found the derivative of the power and we just follow the pattern, and that's all. All right, so that's the whole key here is for you to understand the process. So let's find another question and let's see how you are going to you are going to attempt this one yourself now. Let me see how you're going to play with this one. Many of you will this is a good and a testing question for you. Look at this question that we have. Okay, let me first give you a more easier one. A raised to power okay, can you solve this? Give me my answer quickly. Do we have an answer yet? What's the y over the x of this? What's the y over the x of this? What's the y over the x? Of course. Okay, it looks like some of you are still struggling with this. Okay, first thing I will say is the first thing you want to do is to identify your fx. Your fx is the power of the natural variable, and this is 3x squared plus 2x. So you go on to find the derivative of that, which is 6x plus 2. Okay, so this is 6x plus 2. Good. So now that I've gotten that, all I want to do to find my dy over dx is repeat the same thing as I said already. That will be a 3x squared plus 2x multiply it with the natural logarithm of the variable power alone, or the variable power, that will be log AEA, then multiply with whatever your derivative was, 6x plus 2. So that means your dy over dx here will be equals to 6x plus 2 a raised to power 3x squared plus 2x multiplied by log EA. How many of you got that? How many of you got this answer as your answer when you tried it? Okay, let me quickly ask quickly. How many of you are following? You understand what we're doing? If you know you're following, can you please indicate you really understand what we're doing? Okay, if you know you are following, please can you indicate that you really understand this variable power, the derivative of variable power, you understand? Okay, that's nice. I love to hear that. Is anybody having an issue in understanding this? Okay, looks like you guys are getting it. That's so delightful. So this question, which is going to be the last around variable power, I want to see what you're going to do. This question is coming hot. Let me see who is going to get this. I saved it for the last so that at least we would have gotten people flowing well. Look at the question. This is the question. So this is the question. Y equals to a raised to power log e k x squared. Y equals to a raised to power log e k x squared. So can you make an attempt on this? Of course, this is quite interesting. So you just actually don't get intimidated with the question. No, I'm just being, I don't know, is this sarcastic or something? It's quite very simple, right? It's quite very simple. You just need to follow the same process, right? It's the same process. Okay, so let's go with the process together. So we have y being equals to a raised to power log e, then we have kx squared. So the first thing to identify is what's your fx. So fx here is the power of the variable, which is x, which is a. The power of a here is log e kx squared. All right. So you need to go on to now find the derivative, which is one of the things I told you when I was explaining. I told you that the power can be anything. Don't get too used to the power being 2x or something. Look at, in this case now, the power was a log function, a logarithm function. So what do you do here? You differentiate the logarithm function. So how do we say we used to solve logarithm function before? Have you forgotten? Don't forget, you know, in the two now, you will take this as a function. That will be kx squared. You find it derivative over the normal function. So what's the derivative of this function? The derivative of this function is 2kx. I'm sure you agree with me. That's derivative. We say derivative over the normal function, which is kx squared. I don't need to be doing so much of this because I believe we just solved logarithm function some minutes ago. So if you followed me during logarithm function, what I told you to do is you identify this place as the fx, and then you find the derivative, and then you divide by the function. Derivative over the function. So this derivative 2 times kx over, so this is how you do it. So of course this will give you what? 2 over x. Am I right? That's 2 over x. So that's the derivative, that's the derivative of all this function on top. All this function on top, the derivative is 2 over x. All right. So I want to now go on to find, using my the method of finding the derivative of variable power now. So if I wanted to find the derivative of variable power, what I said you should do is that you say the y over the x is equals to, you write that function, that will be a raised to power log e kx squared. Then you will go on to multiply with the natural logarithm log e of the variable power, that is log e a, then multiply by the derivative of the power, that's the power here, that's 2 over x. So if you look at this now, you will see that your answer will be 2 over x a raised to power log e kx squared multiplied by log e a. How many of you got this answer? How many of you got this answer, this final answer? You know you got this answer, can you signify quickly? So, okay, I like that. Looks like you guys are really on point this night. You guys are really understanding this thing, which is a delight. That's really great. Oh, that's really great. That's nice. So, it's just, I just followed the same process. There's nothing I did different. You repeat the function, whatever the function was, use it. I repeated it, then multiplied by the natural logarithm of the variable, which is a. That one has always been the same thing. Then multiply by the derivative of the power. So we went on to do the derivative of the power here. This was the power, obviously. The power is log e kx squared. So we found the derivative of the power to be this, which is a logarithm function, which I explained some minutes back. So that's just the way you do it. And you see that it comes out very neat. So now, we will be going into inverse circular functions. Very, very important aspect also. Inverse circular function, which would be a very important aspect also, because when I say inverse circular function, I remember I said it while starting the class. That's an example like when you have arc sine x, arc cot. Imagine you have arc cot x. You know, as I told you already, it's the build up of all these things that makes you to understand calculus. So it doesn't jump on you. It's the fact that you understand every bit of all these small things. You understand logarithm function, you understand variable power, you understand polynomial functions, you understand every bit. You understand circular function, because we have explained circular function in previous classes. That was when we had sine x and we were trying to find the derivative of sine x. We have done those ones in time past. Now, if you are now having inverse of circular functions, like imagine you have cosec arc cosec of x or arctan of x. So you will be so surprised that this is so simple. That's one thing I know. It's all these things are always looking so intimidating, but in the end, they are just very simple. So the only reason why students miss it is because they don't get to flow with it. All right. I have not asked you guys to give a thumbs up tonight. Who has not given a thumbs up to this video? Who is there that you are yet to give a thumbs up to this video? With all these great things you are learning, you cannot give a thumbs up, Abby. Well done, though. Huh? So now, because I believe I told you guys at the beginning of this class, I said you should go on to find the table of differentiation. So, but just for the sake of those of you that probably you don't have somewhere to get it from, I will give you a bit of it, and then because you will be needing these things I don't want you people to get lost when I'm using them. So that's why I want to give you. So if you have y as all these things, this is going to be your y prime, or sometimes you can see it as the y over the x, whatever you want to see it as. So if your y was sine x, of course, I'm sure you guys know what this would be. Cos x. These are standard identities in calculus. So I want you to start noting them and start cramming them, by the way, because it makes your work easy. Identities make your work easy. If you have cos x, what do you get when you differentiate cos x? You get minus sine x. I believe we have proved all these things using first principle, so you should not be looking at it as something very hard. If you differentiate tan x, we did this also, you will get sec square x. All right, you can write this down if you don't have it before. If you differentiate cosec x, for those of you who don't know what CSC means, that's cosec. So cosec x, if you differentiate cosec x, look at what you're going to get. You're going to get minus, let me just write it as CSC, minus CSC x cot x. Can you see that? So you see how interesting that is. If you differentiate cosec x, you get minus cosec x cot x. All right. If you differentiate sec x, I'm sure you are all familiar with all these trig identities because you know them. You know sec. You know what sec stands for. That's secant of an angle. So if you differentiate sec x, you will get sec x tan hex. These are basic. These are things you should cram. So we're going into inverse circular function, but you will need all these things. So I don't want you to be hacking and getting caught out because we will just pick them. I will not be explaining to you what I'm doing. All right. So if you differentiate cot x, what do you get? You get minus cosec square x. Can you see that? You need to cram all these things. So for those of you that, or the best way to know it perfectly is to use them. So if you differentiate sine ax, you will get a cos ax. You can see the pattern. It's more like you were only that you'll be having a in front. You differentiate cos ax, well, you will get minus a sine ax. So you can see the pattern there. If you differentiate tan ax, of course, you know, you can guess it will go in this pattern, sec square ax. All right. If you differentiate, what about if you differentiate sec ax? Sec ax. Of course, it will follow this pattern also. A sec ax tan ax. So you can understand that you probably just these first ones are the ones important. These other ones will flow along. You just understand the way it moves, and that's all. So cosec ax, of course you will follow with this one. That will be minus a cosec ax, then cot ax. You can see the pattern. That's all. You just need to understand the pattern. If you differentiate cot ax, look at cot here. This will be minus a cosec square ax. So these are basic trig identities that you probably know already. But because we'll be using them, that's why I needed to write it for you so that nobody is feeling like we are doing something very strange. So now look at what we have here. We have inverse circular functions now. An example of that is, let's say you are given y being equals to arc sine x. Arc sine x. So how do you differentiate this? Now, this is where you need to pay real attention because now I'm going into the explanation of inverse circular functions. So the very first thing, you will notice the pattern. It may look strange when you start, but later on when we do one or two, you would understand the pattern already. So the first thing you want to do, I'm sure you remember when we were dealing with inverse function under mapping, there was something we used to do. You will do something similar there. You see, look at the question you are given. You are asked to find dy over dx of this. So you want to find dy over dx of arc sine x. What do you have to do? First thing is that you will swap the variable. So wherever you see x, you will put y. Wherever you see y, you put x. So in this case now, that means I'll be having x. Now the second thing you will do, I will have x and y. The second thing you will do is that as you are swapping that, you will not bring in sine, arc sine here. You will just put sine. So let's look at the step 1 and step 2. Step 1, you swap x for y, you swap y for x. Then you will change, instead of writing arc sine, you just write sine. So that means x equals to sine y. So now, of course, we have done this before. You want to do it again, where we will now be finding the x over the y. Of course, and you know what is going to happen eventually. After we're able to find the x over the y, you will now invert it to find the y over the x. I'm sure you know the pattern already by now. Now, if you look at what we have here, the x over the y, you should know what it will be. Because look at it here. When you are differentiating sine y or sine of anything, I'm sure you know x could be y, could be p, could be anything in this place. So in this case now, you're having y as the thing here. So if you differentiate sine y, what do you get? You get cos y. So that means differentiation of sine y will give you cos y. I believe everybody agrees with me on that. Now, this is where you now need to pay real attention. Guys, tell me if I'm correct or not. That it's permitted for me to write something like this. Tell me if I'm correct or not. That I can rewrite this as this. Please tell me if I've done anything wrong. I want to get your feedback. Have I done anything wrong to write, instead of writing cos y now, I want to write it as square root of cos square y. Have I done anything that is beyond the ordinary? Look at, I wrote cos y. Now I'm writing it as cos square y, square root of that. Of course, I've not done anything wrong, because if you go on to follow your normal understanding of mathematics, of course, I'm sure you know cos square y is the same thing as cos y, everything all square. I'm sure you understand that. I'm sure you are not trying to, so you know this is the same thing as this. So if I have the square root of this, of course, it's the same thing as cancelling it out, which still brings me back to what I wrote initially. So I have the x over the y. Now, I will no longer be writing the x over the y as cos y. Instead of writing the x over the y as cos y, as this, I'll be writing it as square root of cos square y. So now, I'm sure you all understand what is happening there. I'm just changing the form. That's all I'm doing here. I'm changing the form. And I'll tell you why I'm changing the form very soon. The reason why I'm changing the form is that, see, I can see sine y here. I want to do something. You will see what I'm going to do now. Look at it. From our identity, which I believe everybody here can relate to it. I'm sure everybody here agrees with me that sine square x plus cos square x is equals to what? 1. Am I right or wrong? Do anybody disapprove of that? So now that I have, of course, I could use y if I wanted to just conform to what I'm writing here. Instead of using x, let me use y. Sine square y plus cos square y will be equals to 1. Now, if I have this, cos square y will now be equals to what? Cos square y will be equals to, look at it, will be equals to square root of 1 minus sine square y. Are you seeing the way I'm solving this? So cos square y now will be 1 minus sine square y. All these things I just did now is common trig identities. So I came from here, instead of writing cos y now, I decided to write square root of cos square y, which is still the same thing as cos y. I just wanted to change the form because of where I was heading. Now I've gotten here now. Instead of writing cos square y now, I want to write 1 minus sine square y. The reason why I did this was because I was able to see that there is a sine y here. Sine y was equals to what? X. So if sine y is equals to x, and I'm sure you all agree with me that sine square y is the same thing as sine y all square. You all agree with that. Nobody is here not agreeing with that. So if that's the case, that means if sine y equals to x, that means sine, can I rub this top up so that you people can flow well? I don't want anybody to have any issues at all. Permit me to just rub that first one up. So now from this place here, from what I'm starring here, from this star, we said x is equals to sine y. So if that's the case, I'm sure you agree with me that x square will be equals to sine y all square. And that means that x square is sine square y. So that means wherever I have sine square y here, I can go on to put x square. So I can write this as equals to square root of 1 minus x square. Don't forget this was the x over the y. Now, we're getting closer to our answer. We were told to find the y over the x. This was the initial question they gave me. Don't forget, y was equals to sine square arc sine x. So I want to find the y over the x of this arc sine x. But I could not go straight into doing it because that was not very possible. So I went through an indirect way. Now I changed x to y, I changed y to x, and I got this expression. Now I went on to find the derivative of the x over the y rather than doing the y over the x, which that was the most possible one here. Now, the x over the y, of course, because I knew that from my identities, I know differentiating sine y will give me cos y. Now, the x over the y, instead of writing cos y now, I went on to write it as square root of cos square y. Instead of writing cos square y now, I went on to write it as 1 minus sine square y. Now, I remember that x was equal to sine y. So obviously that means sine square y will be the same thing as x squared. Now, my final answer will now be, now I've gotten the x over the y. The x over the y is this. That means the y over the x will be equal to 1 over, of course, I'm inverting it now. That means I'm taking the reciprocal now. So the y over the x will be 1 over what I have here, square root of 1 minus x squared. And that's my answer. Now, if you want to go on to put your x squared as sine square y, that's still okay. So that's just how you do that. Now, let me know, you people are going to try this next one because I would love to see you rock this also. So can you go on to find when y is equals to arctan x? Arctan x. Can you try for arctan x? Can you try for y being equals to arctan x? Just make an attempt and then we'll do it together. Y equals to arctan x. Can you just give no, we're going to get, somebody's talking about chain rule. We're going to get into chain rule probably next week. Sorry, this week. Well, you understand that I don't want to rush any of all these things. So we're moving step by step. Chain rule, product rule, quotient rule is the next thing on our agenda, but we can't do that this night. So we will just be ending with this inverse of circular functions. So can you quickly do this? Can you attempt this? Follow the same step I just did. Can you attempt this quickly? So what did you get? What did you get as your answer? Okay, it looks like somebody has gotten an answer. So we're going to do it together also. So look at it and look at how simple this is. It's step by step. You don't have to panic. I understand that was the first one. So of course, if it was a bit unclear, that's not an issue at all. Look at what we have here. Y is equals to arctan x. So look at the procedure we went through in the very first one. The procedure was what? We decided to swap x for y and y for x. That means where y was, I put x. Where x was, I put y. And then I change this to tan. All right, good. So instead of going on to, now I'll be doing the x over the y now. So the x over the y is what I'll be doing. So look at from here. If you are differentiating tan y, what do you get? Of course, you get sec square y. That's by default. That's an identity. That's why I wrote it for you, so that you will not be asking me what am I doing. That's why it's still on the board, so that at least you can relate to it. Now, again, I've said this before, I've said this time and time again. If you don't know your trig identities, you're going to have serious issues with calculus, especially circular function aspect, either inverse circular function or the normal circular function. Because when I see sec square y now, can you remember there's an identity in trigonometry that has to do with sec square y? And what is that identity? The identity said that if you have sec square y, I can also write the x over the y as 1 plus tan square y. I'm sure if you remember this, then you're doing great. So now, if this is the case, of course, I don't need to, let me tell you the rule here. The first thing you want to do is to always try to drive towards whatever your x was. Let me tell you, that's the main thing you need to always do. Try to drive towards, your x here is tan y. So now that I've seen that my tan y is coming up here, of course, this is, if we have tan square y, then that means this will be the same thing as x squared. If x is tan y, that means x squared will be tan square y. So since I can see that this is conforming to my x, I don't need to do much anymore. I just need to go on to invert this to do the y over the x. So the y over the x will be equals to what? 1 over 1 plus tan square y. So now, if you want to leave it this way, you are perfect, you are good. It's not an issue at all. But if you want to make it in terms of x, the y over the x will be equals to 1 over 1 plus x squared. All right. So it's that easy. And now, can you try for y being equals to cosec inverse of x? I want you to try for cos x and cosec inverse of x. Try for cos x and cosec inverse of x. That means do for these two both together when y was equals to arc cos x and when y was equals to arc cosec x. Can you do for these two? And let's see where it takes you to. So these are things you can always play around with, so that you don't become you don't have any issue with anything at all. These are all possible questions also for you to find the inverse circular functions of all these things. So do for cos inverse of x quickly, and let me see what your answer will be. If you have cos inverse of x, what's going to be your answer? Cos inverse of x, what's your answer there? How do you go about it? Of course, the first thing, when you have y being equals to cos inverse of x, what you want to do is to change x for y and change y for x. So you have x equals to, so you have x equals to, now you just have cos y. I'm sure I reminded you, I told you how to solve this already. You change x for y, you change y for x. So, all right. So the next thing you want to do now is to find the x over the y. I'm sure you understand the process at this point. So if you find the x over the y, what do you get? If you're differentiating cos y, you'll be getting minus sine y. That'll be minus sine y. Step-by-step process. Minus sine y. Good. So what do you want to do next at this point? Of course, we did this already before. So you want to go on to write your this your function. Instead of writing it as minus this, you want to write it as minus square root of sine square y. So you want to write it as this. Sorry, the x over the y. I'm sure you guys are flowing with me. You want to write the x over the y as this. We have done this initially. So this is the same thing as this. If this cancels this, you'll be left with this. But you are bringing this way so that at least you can move somewhere. So, and I'm sure you agree with me that it is very okay for me to also write it as minus square root of. Now, you know that sine square y plus cos square y equals to 1. So this will be obviously equals to 1 minus cos square y. I'm sure you all agree with that. That's what we have inside the square root here is the same thing as what we have right here. So this is the x over the y. Don't forget, I told you that you are always trying to conform this to your x. You're trying to conform this to whatever and you can see your x is already coming out here. So you know you're in good shape already. All right. So this is the x over the y. So if I want to do the y over the x, the y over the x will be the inverse of this. That will be minus the inverse of this, 1 minus cos square y. There's a minus here, don't forget. You just make the inverse of that. So, and don't forget, if your x was cos y, that means your x square will be cos square y. So obviously, I can rewrite this. This is a good form. You can leave it this way if you need to leave it this way. Or you can leave it as, writing this as x square here. How many of you got this answer? This particular one for cos inverse of x. How many of you got this answer? So I'm sure you are able to flow. Now, let's do for cosec inverse of x. Cosec inverse of x. Now, cosec inverse of x, this is obviously still going to follow the same thing. What are you going to do? Sorry, at this point, I need to be very quick. We're not going to obviously come back to this anymore. So I want to see how to make sure the understanding is perfected in everyone. So when we have this, of course, you do the same thing. You will have x equals to cosec y. That's the first step, which we have always done, right? So in this case now, what do you want to do next? You want to do the x over the y. The x over the y is what you want to do. So this is why you need your identity. If you don't know your identity here, you will be having lots of issues. So when you differentiate cosec y, what do you get? Look at it here. Cosec, this is it. So you get minus, let me just use CSC, please. Cosec y. Of course, you understand why I'm using y. In this case, is y. Y is our variable here, not x. So this is what we get. So for those of you that are probably wondering what I'm doing, just look at your identity. That's exactly what the answer will be. So now, look at what I'm going to do. For those of you probably having any issue here, this is what I'm going to do. Please pay attention. These are places where some people may probably be having some issues. This is, of course, this first two steps, I'm sure you understand it. I did the same thing I've been doing all along. And I went on to differentiate this. So I did the x over the y, which is this. I just brought this out from my identity. Now, for me to go on now, I want to change this sum to something. Look at what I'm going to do. I will leave the cosec y. But I remember something. In case you have forgotten, let me remind you here that cot, what is cot square x? Or when we're talking about cos square, what is cos square x? cot square x is equals to cosec square x minus 1. If you remember this, I don't know if you do, cosec square theta, when we were doing the identity, we remember that cosec square theta is equals to 1 plus cot square theta. This is one of the identities under trigonometry. This is one of the identity. So from here, obviously, you know that cot square theta will be cosec square theta minus 1. But in this case, we're using y. So we will be having this cot square, this thing now. Let's first of all write it as square root of cot square y. Let's first of all write it as that. I'm sure you know what I'm doing here. This is the same thing as what I have here. All I'm just doing here is changing the form. So I had cot y here. I'm bringing square root of cot square y. That means if this square cancels this square root, I'll be back here. So I've not done anything wrong or unmathematical. Now, what's the next thing? The next thing is for me to now bring in my identity inside there. So I'll be having this equals to minus cosec y. This square root now will house this thing. I will have cosec square y minus 1. Can you see that? So what's going to happen here? This is my answer, by the way. So this is the x over the y. So that means the y over the x will be equals to, of course, there's a minus here. That will be minus 1 over what I have here. Cosec y square root of cosec square y minus 1. This is just based on what you can see. Now, if you look at what we have here, my cosec y was x. So that means I can really write this as minus 1 over, there's a minus here, minus 1 over cosec y is what? Y, x is cosec y. That will be x, then square root of what? This one, if x is cosec y, that means x square will be cosec square y. That will be x square minus 1. How many of you got this answer, this particular answer? This is the y over the x. When you are dealing with the circular function, the inverse circular function of cosec x. Okay. Can you attempt these two quickly and we'll round off for the day? These two. I want to be done with this because I don't want to drag this over. Can you attempt these two quickly? Arc sec of x and arc cot of x. Those are the last two questions before we call it a day here. So arc sec of x and arc cot of x. Can you attempt it quickly? So I will know that nobody is having issues in inverse circular function again, and then we know that we are done with this, and the next time we'll meet, we'll be going into something else. Can you make an attempt on that quickly? Okay, so I'm going to be doing mine here. So I have y equals to arc sec of x. Again, the same rule. Put wherever you see x as y, put wherever you see y as x. So this will be x equals to, you remove the inverse now, this. So I'm going to act like I'm doing dx over the y. Not I'm going to act, I'm actually going to be doing it. So I want to differentiate sec y. Of course, I told you, if you don't know all these things, look at it. If I differentiate sec x now, look at what I was going to get. So I'll just follow the same pattern. That will be sec y tan y. So don't ask me how did I get this. I got this obviously from the identities. That's why I said you have to note your identities. So the x over the y is actually this. Good. So what do we do next? Of course, I'm fine with seeing my sec y because I told you, you're always trying to conform it in such a way that you'll be seeing this your x. So, but this one, do you remember the identity that associates tan and sec? There's an identity. Don't know if you remember it. Do you know that sec square theta equals to 1 plus tan square theta? I don't know if you remember this. So that means tan square y, in this case, will be sec square y minus 1 based on the identity which I just wrote. This is all trig identity. So I can write this as sec y. First of all, let me go on to write this the way we used to write it, where I will write this as square root of tan square y. I'm sure you remember, it's a principle now. You should be able to understand what we're doing. So I'm changing this form, only this one. You'll be asking, why am I changing only tan? I'm changing only tan because I told you, always be moving in direction to ensure that you are bringing out, you are seeing x, which is sec y. So since I can see sec y, I want to leave it like that way. I'm still okay with that being there. But this one is the one I want to work on majorly, this tan y. So, and for me to change tan y, I change the form to square root of tan square y, which is the same thing as tan y. I'm sure you agree with me. So now I can go on now to write this as sec y, then I'll write my square root now. Wherever I see tan square y now, I want to put in sec square y minus 1, according to the identity under trigonometry. So look at it right there. So this is the x over the y. This thing I'm writing is the x over the y. So that means the y over the x will be equals to, of course, the inverse of this 1 over sec y square root of sec square y minus 1. All right. So you can leave it this way if it's okay for you to leave it this way. But if you need to put it in this x form, of course, the y over the x will be equals to 1 over your sec y was your x. That will be x, then square root of sec square y. If x was sec y, that means x square will be sec square y. This will be x square minus 1. How many of you got this? How many people got this answer? This is then the last question for the night. How many of you got this answer? I hope nobody is having issues. This is the same protocol we've been following. So I just want you guys to be very much familiar with every aspect. I don't want to leave any stone unturned. That's why I'm trying to ensure we cover up everything, so that at least if you need, for those that needs to go back to this, you can have an opportunity to see something to go back to, so you can easily relate to this. So let's do the last but not the least question we have right here. That's cot inverse of x. So you have cot inverse of x. Cot inverse of x, and you have cot inverse of x. What do? I told you already. The first thing you swap, you will have x equals to x equals to cot y. That's the first step. All right, cot y. So you go on to act like you want to do the y over the x. Sorry, the x over the y. I always keep saying you act like as if you want to do it, but actually you're going to do it, by the way. So you're not acting, you're going to do it. You'll be doing the x over the y. So of cot y. So you have to, this is why you need your identity. So look at it now. Cot x, whenever you're finding you have the cot of an angle, the derivative is minus cosec square. That will be minus cosec square y, because y is the variable we're dealing with here. All right, good. So what's the next thing to do? Now, you need to remember your trig identity. I've been saying this before, and I keep saying it. If you have issues with trig identities, you would have serious issue with calculus. Cosec square y will be equals to 1 plus cot square y. This is a trig identity. So that means you can easily use this, obviously. So now the first thing you want to do is I want to first act. Okay, I don't even need to do so much of acting here, because this is already looking very much like it's having the square already. So it's, the reason why I used to act that way was so that I'll be able to bring it using the trig identity. But now it's the same cosec square y. So I don't need to do anything here. I just need to write minus, then I put that inside 1 plus cot square y. All right. So I just need to put that directly. So this is the x over the y. So that means the y over the x will be equals to 1 over, of course, there's a minus there. So 1 plus cot square y, which is, it's okay like this if this is what you are told to do. But if you want to leave it in terms of x, then you go on to now write it as minus 1 over 1 plus, this will be x squared. Because if x is cot y, that means cot square y will be x squared. So, and that will be the final answer there. How many of you got everything? You got this one with every other one. You got this one. You really got this answer. This is the last question for the night. Okay, so I can really say that if you put all these things we just did this in this particular class, if you put all this into practice and you go, of course, you have to go back and now attempt lots of questions, because all these are all you need to know. The next thing is for you to put in lots of practice. So you need to go on practicing lots of questions, and this will really aid your ability to be able to solve questions anywhere you find yourself. So guys, can you give me feedback? How did you find today's class? How was it? Did you really understand the concepts that we have explained in this class? How do you feel about the classes? How do you feel generally about the classes this weekend? Did it give you more clarity? Do you really understand calculus better? We started with the first principle. The first principle, using first principle, then we went deeper into it, then we went into different functions. Now we have quite a lot still in front of us. I need to tell you that. I don't need to mince what I don't need to mince word. You really have a lot in front of you, because we've not gotten into integration at all, and even differentiation, we still have more things coming. So we have to keep pushing. There's the exam coming up in front of you, and I need to say this: the preparation we'll be doing here, you can't go wrong if you really follow through on everything we're doing, because you will see calculus as being very easy. I can assure you. That's what we want to do right here. So please ensure you put all these things in practice. Get a good note. Solve questions. Go online. Get past questions. Solve questions so that you can get to understand these things more. Don't forget, by the way, this week we'll be having a beautiful test, right? I'm sure you guys remember. So we're having a beautiful test. So please go through all these things. You know how the format is going to be. So this is quite a good time to end this class. Thank you very much for joining, and I wish you all the best. Prepare very well for your exam, put in the time, and do your best. All right, take care of yourself. Bye-bye.